so much. I believe there's some celebrity has passed away today. So in Vile Parle there's a funeral. Pankaj Dheer, he's passed away today. So there's some traffic celebrity movement happening that is also contributing to the entire thing. But thank you so much for joining us here today. My name is Anil Chopra and I head research at CMR and I'm the research editor for cyber media group of publications like DataQuest, PCQuest, Voice and Data. So I am the research editor there. So today we have come to discuss a very, very important topic on AI. And that is basically the essential infrastructure required for running AI workloads. Okay? We talk about so many other things, but I think it's critical to look at what sort of infrastructure is required, because at the end of the day, any AI application is as good as the infrastructure that it's running on. Okay? And it becomes very important as the workload grows, can the infrastructure actually handle it? And here when I talk about infrastructure, I'm talking about things like memory, storage, the critical elements which are actually, be able to power the applications. Memory, for example, you need right response time, latency issues. Every millisecond counts when you're looking at an AI workload which requires real-time decision making and things like that. So you need the right memory architecture, you need the right storage architecture, because at the end of the day, data is going to grow, right? The 25-30% year on year, the data is growing. Okay. The challenge is with AI workloads, and I was discussing with Shyam outside, offline, that with AI workloads, they require more power. 25 to 40% more power is required. So on one side, you need the right performance, but the other side, you need more infrastructure, which is going to increase the cost of the power consumption. So it's important to balance the two, because I'm sure all of you will be having some sustainability goals to reduce the carbon footprint of data centers, isn't it? And NASSCOM also says that most enterprises have some goals by 2027 in the next 2 years. They have to reduce the carbon footprint of the data centers. So on one side you have to manage that. The other side you need to ensure that your critical infrastructure is in place so that your applications can deliver. That's what's critical. So is your infrastructure ready? If not, what is required to make it ready? So today we're going to delve into some of these things more deeply. Don't want to give a cursory overview of things. We want to delve deeply into some of these things which matter a lot. And it's important when we get deeper into it, that's when you really understand the relevance of these things. Because many times people might say, memory, what's the difference? But ultimately there's a lot of things that matter. So we're going to discuss that. We're going to have sessions on that, and then we'll have a discussion with all of you to see what you feel, what sort of workloads you are running, what sort of priorities you have for infrastructure. After listening to some of these thoughts, I'm sure some of these mindset will change to some extent. I'm sure it will get influenced. I hope from what you hear. A lot of good technical insights we have from our speakers today, and then we'll proceed with the roundtable. So that's in a nutshell what we're going to do today. And so to start off, I'm going to invite Rajesh Gupta, who is the director and country head for sales for Micron Technology, to give you an overview of some of the things I talked about and delve deeper into that, and we'll proceed from there with the rest of the session. So thanks all for coming, and Rajesh, over to you.
Good evening, very warm welcome again. As Anil said, my name is Rajesh. I have with me several of my colleagues. I just wanted to spend a few minutes before we get into the next level of details. Micron, I'll share some details about what Micron is, what we are doing, and how are we making a significant change and driving the direction of AI adoption that is going around in the world. But also wanted to spend this time to establish a connect with you all. The reason is very simple. You've all used systems, all kinds of systems in your organization, clients, servers, at the back end, even today IoT, and everything requires memory and storage. Memory and storage has always been a very commoditized product. One of the reason is for your laptops, desktops, and servers. Memory is a jet extent. You can take Micron in your laptop. You can flip the cover. You can remove Micron SODIMM and insert a Samsung SODIMM or somebody else's SODIMM, and vice versa. Same in your servers. We use registered DIMMs. These are commoditized. These have been commoditized over a period of time. However, the game changes significantly with the deployment of AI as well as large end cloud services. The reason is very simple. Simply speaking, as we understand internally, as we look at as a memory and storage company, we see AI as massive manipulation of data in real time. That has to happen in memory, and that is why in the last 4 or 5 years there has been a significant transition in the way we look at memory storage as well as some of the new products. And in fact, my colleague Rohit, who is within my team, head of my technical sales organization, will dwell much into some of these details. All of you have heard about high bandwidth memory. AI workloads is about high bandwidth memory. High bandwidth memory is not commoditized. So our high bandwidth memory is very different than our competitors. Today, when NVIDIA or AMD, if you take an NVIDIA and AMD platforms, it goes through a significant amount of different mechanism. Core memory is made on our side. We have to work with NVIDIA. We figure out there has to be an intermediary company. We figure out how the interfacing will happen. Our chips move to TSMC where the final packaging will be done, and then it will be shipped to a customer. So that has brought memory and storage into a very different perspective. The challenge that we have seen, those of us who have spent most of our time, almost all of our careers in IT, memory and storage never typically come into any discussion than when you are looking at your infrastructure requirement. Variety of reasons. First, I've already said, it's a commodity product. From the organizations you buy your hardware, it's a commodity for them also, because it is swap products. Third thing is their own expertise. Is that an area of expertise for them? Not at all. Because they are working on your requirement. Once the requirement study is done, there is a commodity product, the cheapest commodity product usually will find its way. And that is why memory and storage never becomes an integral part of your discussions when you're looking at your infrastructure. But that's not how the things are when you're looking at an deployment. And that's the long part of my introduction. That is why we have started doing this connect events, where we are trying to connect with leaders like yourselves. Our objective, obviously none of you is a customer who is going to buy our DRAM or a SSD card. So the idea is, but how do we facilitate that gap, that the hardware vendors who sell hardware to you neither have the wherewithal nor the understanding at the local level to bring what changes, what deployments, what architectural advancements are. That's our objective. So, quick thing about Micron, I was just having a chat with you, sir. Micron discovered India very late, 2019. 2019, there was no footprint. For a technology company, not even to have a development center in Bangalore or Hyderabad, will tell you the level of gap. But my God, we have covered that gap so significantly that as I'm talking to you, exactly 6 years after the first GDC came up, and then I joined in May 2019 to set up the sales operations. We now have around 4,000 engineers between Hyderabad and Bangalore. We have a sales organization. And in order to compensate, if I can say it in a joking manner, for all the 2.5 decades that we missed, Micron is the company that made the first announcement of the semiconductor manufacturing in India. And I will share some pictures about it. It has come up very rapidly, and I'm very happy that this December, the first shipment will be made of a DRAM product completely manufactured in India to a global customer.
Wow.
That's the kind of. Sorry?
From where exactly?
So I have some details. I'll share those details. Hold on. time, if you look at the universe, there are only 3 memory and storage companies, two Korean, and Micron is the sole Western Hemisphere US company, but Micron is not a Silicon Valley company. Micron is headquartered in Boise, Idaho, which is a Midwest, almost on the Canadian border. I find it very ironic that in the US, Idaho has always been known for potatoes. So if you ever go to US, you go to a McD, it will say French fries made from Idaho potato. But the second important thing is, 47 years back, 2 engineers.
So anybody chips?
Chips. And look, it's a funny story. The 2 engineers who used to work in Texas but were from Boise, they went when they were looking for seed money. The seed money was given by the biggest potato farmer in Idaho, who said, I know only one kind of chips. They have never disappointed me. I hope the other kind of chips will also not disappoint. So he was the first guy who gave seed money to the 2 engineers who founded Micron in 1978. So we are still headquartered in Idaho. We have 2 big fabs. Another fab is coming up in Idaho. So essentially, it's a long legacy of memory and storage is all that Micron does. That's our area. 47 years. That's what Micron has done. Important thing is things like 60,000 patents. That gives you the grain of the company. Very obsessed with generating newer technologies, creating new IP. So we always see success measure as to how many patents over a period of time we have created. We just, because of potato farming, Micron's fiscal year is 1st September to 31st August, because that is how the potato cycle works in Boise. So we just declared our last fiscal annual results in the 2nd week of September. So 37.38 billion, so it's a pretty large Fortune 500 company. We have, and it's a very, another important thing about Micron, many semiconductor companies are very leveraged in some very specific places for manufacturing, not for Micron. We have 11 manufacturing sites, which now 11 includes Sanand and Gujarat. And that diversification means that even in the peak of COVID, our supply chain was never tough. The other important thing is, there is nothing that we do in China that we don't do anywhere else. China represents only 5 to 7% of our manufacturing output. Given the way things are between US and China, you know, anyway, our business in China is always at risk. So, very diversified supply chain, and you know, we have manufacturing across, very well spread across the world, and then very proud that India becomes a part of global supply chain setup. You know, since we do memory and storage, almost every user case we have products. Now, products that we do for 5G versus automotive versus data center, the starting point is a wafer, but the end product and the packaging is very different. For automotive, even the qualifications are very different, because we have to do automotive grade parts. The testing is very specific. For automotive, in fact, we have only one captive factory within US. We don't do automotive part anywhere else because we're dealing with lives here. So, but every use case that you see, we do products. And this is another representation, whether you look at cloud, whether you look at edge, different kinds of DRAM and different kinds of SSD products. Starting point is always a component and a chip. A lot of customers will buy chips and then they will do all their own modules. For example, Gujarat, we will do components as well as modules as well as SSDs. There are a lot of customers who will take chips from us and then they do their own boards. So our entire range is comprehensive. We sell products in 2 brands. For most of our automotive, embedded, industrial and enterprise products, we sell products under the umbrella Micron brand. But for our consumer products, if you go to Amazon.com, you won't see Micron, you will see a product called Crucial by Micron. The simple reason is consumer products are engineered and architected very differently, right? Consumer products don't need the best DRAM output, best NAND output, controllers, and the specifications are very normal, if I may say. So in order to bring the differentiation, we do the business in consumer products are. So if you were to go to Lamington Road, you will only see Crucial. But otherwise, when we sell, if you open up your laptop, the HP laptop, if there is Micron in it, it would be a Micron DRAM or a Micron SSD. As I'm talking to you, what time can do, just 18-20 months back, we were in a post-COVID recession. Everybody knows that, post-COVID, first there was a demand upsurge because everybody wanted investment in hardware, every family wanted 2-3 laptops, right? Every organization wanted to empower their employees with desktops or laptops so that they can work from home, etc. And once that demand went down, there was a disaster in the semiconductor industry, at least the memory and storage industry. We went through one of the worst time in company's history, 6 straight quarters of operating loss, because memory, as I said, memory as a product, if you walk into a Micron manufacturing plant, or if you walk into a CPU manufacturing plant, the plant, machinery, design, everything is same. But the output, one place it's a high-tech product, and one product is a commodity product. So commodity goes through commodity cycles, and commodity, at times the price is dictated by the market, and then there is oversupply, and then this Chat GPT, I think, completely changed life for everybody, including for us. Success of Chat GPT meant the other big four, they are desperately looking to bridge the gap. And how do you bridge the gap? By increasing the infrastructure. And as I said, any AI is about memory and storage optimization. The game is there. So that has put tremendous pressure on us. Plus, high bandwidth memory is a very new technology, and it has to be customized customer to customer. It's not a standardized product. So that has really changed the game for us. And in order to be ready for the way memory and storage is expanding, we are investing significant at this point of time as I'm talking to you, including the almost $3 billion that Micron has invested in the Gujarat plant. The overall investment plan over the next 10 to 12 years is around $100 billion. That's the kind of memory and storage demand that we see, that our existing infrastructure cannot cope with. This is our, as I talk to you, this is our existing infrastructure, headquartered in Idaho. We have 2 completely new mega fabs coming up. One obviously in Idaho, Boise, because that's the headquarters, and one in completely greenfield in Clay, the name of a city in New York. So much so that it is in a barren area of New York where the entire town planning, etc. is happening. So this will be a big mega fab. If you see China, we do some assembly and test, but only DRAM. Then in Japan, we have both fab as well as we do R&D, as well as we have assembly test. Assembly test is where you do the final packaging. Then in Taiwan, we have significant investment in Taiwan because we do a lot of our server DRAM out of Taiwan. Singapore, we have a fab as well as finishing. Just last month, Micron announced, given the load HBM is causing on all our manufacturing, Micron has announced a completely greenfield fab only to take care of high bandwidth memory out of Singapore. And then obviously Gujarat, very proud that Gujarat now shows up in our map. And Gujarat will also be an ATMP, wafer in, so unprocessed wafer in, and output would be chips and components. And we'll do both DRAM as well as NAND, as well as over a period of time. We also have some NOR business. NOR is always used in your smart meters, etc. Instead of using NAND, the technology used is NOR. So this very diversified setup that we have. Some details about, since I'm talking about Gujarat, it's a massive facility, almost 5 lakh square feet of clean room space. I have an artist impression. So this is the highway when you are driving from Ahmedabad I think towards Rajkot. This is how the building is looking up. If you were to drive past this road, you will see a finished facility, and as I said, first global shipment to one of our global customer, first week of December is the time frame that we anticipate. That was a brief I wanted to share about Micron. Now what we'll do is I Rohit Sharma, who's our lead of technical sales and enablement, and he'll drive you through the entire aspect of how we and some of the key industry leaders, because when we work with Big Five, how are they looking at an AI deployment, how it is segregated, and then what products, both DRAM and SSD, make a difference. I will keep reiterating the fact that at different stages of deployment, you have to make utilization of the right technology, both DRAM as well as storage. Otherwise, your solution is not optimal. The challenge you face is your interface of the OEM who is selling the hardware do not have that experience. Because for them, the box is a box. So that's what the agenda is today.
Thanks a lot, sir.
And we'll continue our discussion.
Thanks a lot, sir. So good evening. A little bit background about myself. I had been always in the software side, and then I moved to the hardware field. With EMC, I worked with Hitachi, 3PAR, Mumbai, HP, and that was all from server storage landscape perspective. And this is my only semicon company, Micron, almost a decade now. But like Rajesh already said, the focus has come in last 5-6 years I can join. And that's why if you have any question, do stop me wherever you have. And there are so many vagaries and jargons primarily from a semicon perspective that we'll try and focus. And to set the stage, like Rajesh has already said, primarily it is a commodity business, and where there is differentiation from a product perspective and how it can change your infrastructure and what all you should be looking in this side, which is so-called commodity. I'll discuss about so many factors which you will see that they can make a lot of difference in your architecture. And that is why this is the next gen storage infrastructure. Memory definitely also will be covered within this from an AI infrastructure perspective. This is the entire hierarchy, and maybe a decade or 2 decades before, there were so many tiers that we had. Those tiers, all of them have gone away. 15K RPM hard disk drive, 10K RPM hard disk drive, then 7.2K RPM kind of hard disk drive, on top maybe 1 or 2% kind of SSDs. From that, we have already come to a stage wherein it is entirely SSD, and only the place that we have left now for hard disk drive industry is at the bottom, possibly wherein we have archival or maybe 15 TB, 16 TB or higher, 16 TB or higher kind of hard disk drives. That moves primarily from a network data lake perspective. For that only, we have launched our Micron 6550 ion drives, 60 terabyte TLC SSDs, and that is only offering from a Micron standpoint perspective, and we have been leading this industry. And there had been a huge disconnect between analysts and the entire semiconductor industry perspective as well. What should be the right mix, whether we should be looking at a TLC SSD or a QLC SSD, and Micron has taken a stand that TLC would be the right fit at this particular point in time, and going forward possibly once we make a lot of changes so that economics falls in the right place, then possibly QLC will make much more sense, which is why we are starting with the TLC kind of SSDs at this point in time for 6550, 60 TB SSD, and huge gain you will be able to get. And from a TCO perspective, your overall TCO at this particular layer will be, from a capex perspective, will be similar to what you can create from a hard disk drive. 16 TB kind of hard disk drives, if you take, similar capex you will be able to get there, and way lower OPEX, which is why from an overall TCO perspective, you will be able to create much denser, so to say, storage for your network data lakes with this kind of SSD. On top of that, you have local data local caching tier, so you can say. So your local data cache from possibly could be created from two kind of drives that we have, 9550 or 7600. The highest performing tier of NVMe SSD, the capacity oriented tier, and something in between, 7600 or the mainstream so-called SSDs from a semiconductor standpoint perspective. And these are only three tiers typically that are there from a semiconductor industry side. On top of that, you have an expansion memory. In case whatever memory you are able to put in your main memory, your DDR5s, on top of that, in case you want much higher capacity, then you can expand that with Micron CXL. This standard is coming up, and possibly 2 terabyte or 4 terabyte you will be able to expand on top of your usual 24 slots that you have in your 2U rack servers. That kind of capacity for in-memory databases, for AI training kind of workloads, in case you want very high bandwidth, very high capacity from the memory standpoint perspective, so you can feed so much. And from an inference standpoint perspective as well, you can do so much tokenization, so much inferencing you want to do, that you will be able to do with this expansion memory. And from main memory side, that tier we are able to cater to our normal DDR5, 128 gigabyte kind of DDR5s you can have. Usually RDIMMs are talked about, and RDIMM everybody knows. But similar to DDR4's LRDIMM, we have now come up with a standard called MRDIMM. In the later on presentation, we have few slides on this new technology as well. And through this technology, at this point itself, you will be able to increase 40% higher bandwidth and 40% lower latency, primarily in a loaded kind of scenario with this technology. We launched this in January of this year itself. So this kind of technology is already there in place, typically not talked about much, but there will be so many use cases that we can discuss throughout, and even in the AI scenario we will discuss those, wherein you will be able to move to an MRDIMM form factor. It goes into the same server, same slot, everything is same, only with Intel it has been launched as of now, Granule Rapids onwards, Xeon 6 kind of architecture. If you have that, then you will be able to use it. Possibly it will come with AMD with Venice, that's what the plan is at this point in time. Then from main memory standpoint, and within main memory as well, you would now see that LP DRAM is making its headway into the data center as well. It has done a good job in mobile segment. It came to the laptop, desktop or the workstation kind of market, and from there it is now coming to the server landscape as well, because power is a big thing. And power efficiency has been in our DNA, and like Rajesh said, there are so many different factors we are thinking about: power, performance, capacity, all this. In each of the products that we will discuss, you'll see that all these three we are catering to. That is why from power efficiency perspective, that LP DRAM will take a lot more, you will make your infrastructure much more power efficient. And LPCAMM2, the same thing that LPCAMM2 is doing to your laptop desktop, that client workspace. Similar to that, we have developed SOCAMMs along with NVIDIA. That is coming in GB300 accelerators already. On top, we have the near memory, the costliest kind of memory, highest performance kind of HBM4 standard goes up to almost 2 terabytes per second. That kind of huge bandwidth and so much real estate at so much less power, this will be able to power the next generation AI kind of workload. The entire suite or the entire tiers you will be able to develop with Micron. That is a unique value proposition from our side.
That can be required to autonomous car also.
Correct. So again, it started with LP DRAM and then it moved to SOCAMMs, and HBM3 is also there. So all three kind of architecture, different kind of accelerators taking those. We'll cover those in the later on slides as well. This is our technology leadership, as Rajesh already highlighted, that we take pride in innovating. So much innovation is there in our DNA. We quickly moved from 1Z to 1 alpha DRAM to 1 beta DRAM to 1 gamma DRAM. Similarly, on the NAND side, we moved from 96 layer to 176 layer to 232 layer to 276 layers now. And in the process, we saw that most of the other players, they were taking the name, taking just the numbers and coming like similar number, 176 layer, they'll come up with 162 layer. while there are so many other innovations that are being done at each of the stage when we are passing from one node to the next generation node, both at performance perspective, power efficiency perspective, the real estate perspective, how many bits per cell would be there, different kind of channels, architectures would be checked at that. High key metal gate technology that we have implemented is way different than the entire industry. We have taken so many different routes than the entire semiconductor industry or from an analyst perspective, which is why we changed our nomenclature and now we have started calling it Gen 7, Gen 8 or Gen 9. But again, the parlance is the same, and we want to highlight that there are so many other factors as well. And just to give you a complete list, just talking about from a DRAM standpoint perspective, but similar applies to the NAND. From a speed standpoint perspective, 1 alpha DRAM was able to go up to 6400 speed grade only. Then with 1 beta we were able to come to 8000 speed grade, and now 9200 MTPS we are already able to go to. From a real estate perspective, you can see at every node level we are able to cut down 30% on the die size. On the same infrastructure, which is why you can see that the kind of drives that are coming every year, we are doubling the kind of performance that is there. With lesser real estate, we are able to give you much more bits, or much more data you will be able to store. And data is where the entire AI is happening. That is why the bit density is of huge importance. Additionally, this is a unique thing that we are doing from a power reduction perspective. At each layer you can see that greater than 10% power efficiency we are bringing at this level, 1 alpha compared to 1Z, the prior node, then 13% efficiency, 20% efficiency. So this is 20% much more efficient than this particular node. That is why at all power performance or from a capacity standpoint perspective, with each node we are able to innovate, and this DNA you'll see in all the products that we'll be highlighting later on. Again, from a vertical integration standpoint perspective, everything happens within Micron. Our own ASIC, our own firmware, we are developing our own NAND. There are only 3 players like Rajesh highlighted. Nobody else other than these 3 has fabs, so to say. There might be so many other assembling kind of organizations which will buy NAND from players, these 3, and then they'll create something or the other. Put together 4 players from DRAM and NAND perspective. Nobody else out of other than these 4 is able to create both NAND as well as the DRAM, the dice, and everything is being done in-house. Before diving too much into the AI landscape, just one technology I want to highlight, and primarily to build on the point that we were initially discussing from a commodity standpoint perspective. DRAM is completely commodity, but there is so many things that you can change just by 1 or 2 specifications. Other than that, it is JEDEC compliant. You can swap out the specifications, everything within the entire semiconductor industry, they are the same. So this is DDR5. The real reason why you are wanting much more DRAM capacity now compared to the earlier architectures is because your bottleneck typically was never there, is never there, and will never be there from a processor standpoint perspective. The bottleneck typically is from a hard disk drive standpoint perspective, and once you move from hard disk drive to SSDs, your bottleneck will move towards DRAM. And the reason is highlighted in this particular diagram, your bandwidths per core. Your system memory bandwidth, it is definitely increasing, but not at the pace we are not able to catch up with the kind of core count. Huge jump you would have seen in the core count, which is why in case you are having a DDR4 3200 speed grade with a 24 core kind of architecture 8.53, similar to create that kind of architecture, you will have to go way higher in case you are going to a 64 kind of core, kind of almost somewhere here you will have to drop to almost DDR5 8800 you will have to replace, so that you are getting the same kind of bandwidth per core. That is why once you are increasing your cores, and that is a job well done by all the processor vendors, instantly the entire industry, the consumer segment is moving to higher cores, but from a bandwidth per core perspective, nobody is chasing. From a specification standpoint perspective, the specification will be pretty similar to what we are making or the entire semiconductor industry is making. You'll ask for a DDR5, maybe a 64 GB, 96 GB or a 128 GB, this much speed grade 4800, or you'll, at this point in time 6400 speed grade is the common speed grade available, and we have also launched recently the 8000 speed grade 128 GB modules as well. So typically the industry would be at this point in time. A few months back I would have said that 64 gigabyte is the best from a TCO perspective. Dollar per gigabyte is the best in 64 GB. 96 GB, although just 50% more capacity, kind of cost was double, and 128 gigabyte was that huge premium, kind of 5 to 10 times compared to 64 gigabyte. Now 96 gigabyte is the most efficient from a dollar per gigabyte perspective. All this remains same compared to all the semiconductor players. All these specifications are same. Only one difference from an architectural perspective. How are you creating that DRAM? There could be two architectures, and again depends upon the same highlight that we were highlighting from a node standpoint perspective. How we move from 1Z to 1 alpha to 1 beta to 1 gamma, at what stage you are in. Since we have been much faster, which is why we were able to create with a single die package. So a single die package or a dual die package, it is a pretty simple kind of design. If you are not at that particular node level, then the only option for you is to create a 3D stacking. 3D stacking means one die on top of other second die, and it will keep on creating that die stack. With that, more complexity is there, more signal integrity issues will be there, TSVs will be there. You'll have to think about all these challenges. The cost will also become high, and to manage all these challenges, your power also will be much higher. Which is why, if you are just specifying it should be a monolithic kind of DRAM, then what are you getting? A 96 GB SDP with all this simplistic architecture. From a performance standpoint perspective, you can see plus minus kind of 5 or 8% differences there, and in some cases this is much better compared to a 128 GB, and there's a huge cost difference between 96 GB and a 128 GB module. So just by buying monolithic architecture DRAM modules, you are getting the same performance with a 96 GB module compared to a 128 GB module. You are saving on cost, and you are saving on power as well. 22 to 24% kind of power efficiency is there. Although what we are highlighting is 96 GB versus 128 GB, this is a dated slide. Now we have also launched 128 GB modules with the same kind of architecture, and that also is giving you 24% power efficiency compared to the architecture. That is the kind of advantage technology can have. And once you specify that, because in case you will just specify DDR5, 64 GB or 96 GB and 6400 speed grade, anything can come. You will have to specify whether it is monolithic or CDS. And at times, somebody can take pride in saying that it is 3DS, because in NAND level, it is actually an advantage. You are stacking more, like I was initially saying, 176 layer to 232 layer to 276 layer. There the game is, at that side the game is different. From a DRAM standpoint perspective, because we are able to create, it is a simplistic architecture. That is.
At this point, sorry I'm intervening.
Yes.
I just want to make this point that I was trying to say. One of the objectives of this session is, no matter going forward when you are discussing your infrastructure requirement, don't accept that these are commodity products. You don't need to, we are sharing a lot with you. Our request is just dwell a little deep, ask more questions to whosoever your supplier is. Just ask, because if you ask, then they will have to go through this. Otherwise, our experience is a monolithic die is a little more expensive than this thing, and the box seller often feels uncomfortable, and they say, "Aap kyun bata rahe ho?" Oh, our only request is please dwell a little deeper into it. It will result in a performance gain. If once a product is put in, it's not possible in a running data center to pull something out. That opportunity is gone.
Yeah. Does that make sense? Any questions or any queries on this?
Just one second. This power, 22% lower power is vis-a-vis what?
This 96 GB modules at a server level, we are able to save you 24% less power
Compared to what?
to this 128 GB modules. So same 2U rack servers, you can have some 2 terabyte capacity built with this 96 GB modules or 128 GB modules. That 2 terabyte that server put together will consume 24% more power in case it was built with 128 GB modules, and it will be costly as well.
Then what is the advantage of building that 128 GB? No, if it is expensive and consuming more power.
Correct.
Sometimes it would be just be a spec, saying I'm giving you a higher capacity module. But if you don't dwell into the next level of detail, this part may not be useful.
Right. So just to give you an example, the way this will lose out and this will win. The tender or the RFP or the requirement says that I want 128 GB into these many modules, okay, and I want to your rack server. Now nobody will give you 96 GB because you have not asked for it. You have asked 128 GB module and the requirement from that particular server OEM is 128 GB modules. But in case you are open to both, and you now know that if a monolithic DRAM is being compared with a 3D stacked DRAM, then 96 GB DRAM performs same as 128 GB DRAM, although the memory capacity is less. If the memory capacity is less, you are getting the same performance, you are getting 24% lower power as well. Then it's a win-win situation. But again, that has to be discussed out. Nobody typically discusses that in the industry.
With 1/3 cost.
Not 1/3, but again, from a premium standpoint perspective, definitely I believe, Sanju, the costing for this will be, I think, this infrastructure itself put together will be, I think, 1/3 the cost overall.
Yeah.
From a premium standpoint perspective, at least this 96 GB versus 128, this will be double the cost of this module to module, right now.
70%, correct.
Correct. So that.
No, other way around. What you are putting, for example, 128 GB. If someone is doing sizing, like in that particular sizing, if we are putting 128 and then we are putting 96, however, good part is 22 to 24% is power, plus there will be cost delta.
Correct.
But again, the salesperson who is doing this box business would, you can say, convince to the consumer
Correct.
that there is less in GB.
Correct, they are less in GB.
Yeah,
Yes.
here you are getting 32 GB less, that is the reason cost is less. Now, when we are comparing, it's all about performance, it's all about the storage, consumption plus bandwidth. The end result will remain same since there is no change in bandwidth.
Correct.
But the issue in question is all about client education. How you can say Micron would pushing this into market, that was 128 GB, what you have is the same capacity of 96 GB. You should not think that there is 23 GB ka differential delta.
Correct.
That is
Absolutely, sir. That is the change, and most of the customers, since they are not able to understand that, and this is not discussed only. And we have a huge team. It is called data center workload engineering team. It is their job to run all these workloads. So somebody from that team would be an MLC expert, somebody would be Word, DLRM, Redis expert. They would have done this testing and then collated these results, and then they came out with the fact that okay, 96 GB module is comparing same as from a bandwidth perspective. So whatever algo you were running, whatever batch you were running, that batch performed in the same time, and but you still have a 96 GB kind of module. All the cost difference between these two would be at least module to module level. This will be double the cost or more than that, because
Apart
96.
from, apart from the costing factor, what I think Rajesh, what you were trying to explain, what you're showcasing right now, okay, to the forum out over here, are these details also published anywhere on
Yes,
the sites
yes,
where you
quite
know, to educate the people, like what you were saying, what Kali was saying. It's more about the sizing. Today when somebody is designing the data center or upgradation also,
Yeah.
or movement also, it is a one-time investment, at least for 3 to 5 years.
Yeah.
And then sizing it again becomes a major challenge because no CFO will go ahead and approve any kind of an investment until it is not justified to the extent it can. So if somebody understands this, you know which component to use, why to use, and how to configure it correctly. Later on, even if you add in maybe a 3 TB also, or even if it's 256 GB, that could be easier. So if you're saying that this has been published, I think
Yes.
that is the first step. That is where the IT guys actually look into and they'll understand, because this I am not sure if everybody is aware of.
Yes.
Or maybe if you can like,
That's the
not just publicize, but also kind of like, spread this
Promote it.
across.
Correct.
That is going to be very important.
Absolutely.
Since we are
This
doing
is
this.
absolutely right, and this is what we have pulled together a lot of this data just because in some of one-on-one discussions with a CSP or an enterprise CIO, we realized that this information was not easily available. And then, as you are saying, once you have done the sizing, I completely agree. You go to CFO and say, look, I want to refine my infrastructure. So, point taken. I think the message being given is how do we proliferate some of this
Yes.
in a very open manner in public domain. Our first starting point was this interaction itself, but we'll do that as well.
So there is a white paper published by Micron already. But again, you are right in pointing out that we are not
How would you
proliferated.
know?
How would you know? Yes, as an end customer. That is why we want to be your partner in your journey, wherever you are from an AI standpoint perspective or from your other infrastructure sizing perspective. We want to partner with you and we'll be able to share all these insights. And behind me there is a huge team, data center workload engineering team. This is their job. They are experts in each of these kind of workloads
Very
and they keep.
Very interesting. I hold a platform engineering as well as a IT infrastructure for my organization globally. But we never bothered about memory. So whatever we bothered about your CPU, GPU, all of these things, we deliberate with Intel, we deliberate with AMD, we deliberate with all of them, but never interacted with VU2. Okay, whatever it's been there, with our own limited understanding, okay, we feel that this is the right categorizations, and accordingly we purchase hardware too, right?
So generally, the Intel and the likes of Intel and such, right? Generally, they don't disclose because the problem is awareness, right? The education. So what I feel here is that it is more of a spreading awareness so that we question them.
No,
The
more
current
importantly,
OEM that we work with, we don't actually question
I
them.
feel that okay, it's more kind of it's kind of it's so much commoditized. Okay, people feel that okay, it is obvious. Okay, so it is what to do. There is no technology all about. Okay, so we feel that probably others are more technically aligned than this one.
And the interesting thing is in a modern server configuration between DRAM and SSD is almost 50-60% of BOM.
Yes.
Treated as commodity, which is no, for us, we don't see that as a commodity because all those things. But you're right, I think the point for us, Rohit, is how do we push it forward so that, decision makers at least have an access. So,
Excuse me, just for my understanding, it's 96 versus 128. 128 किसका product है? Your product? So,
no, all of us have
All of
it.
us have. So that is why initially we started with
then are you
that.
comparing two of your products?
No.
This 96 GB is single die package from Micron. This 128 GB 3D stacking is from another semiconductor player. We also have 128 GB that is also single die package. So we only create single die package or dual die package. We were not required to because our architecture was already advanced, which is why our die size was smaller. We were able to create with that small die much higher capacity, which is why we are on this side. They were not, which is why they are on that side, and they are creating 3D stacking one die on top of other so that they get higher capacity. But there are challenges associated which they will have to deal. That is why higher cost, higher signal integrity, higher challenges. TSPs also have their toll. All that happens. But other players also have 128 GB, 96 GB, everybody has that. The only architecture is the difference. That is why we initially started that it is a commodity business.
Just
So
because of
na-
multi-dies package, right? This one.
Correct. That is 3D die stacking. That architecture has inherent limitations. If we would have created that, we would also have the same kind of limitations.
So in terms of products, since Rajesh again coming back to you, when you have showcased the one of the slides where there was a commodity product which is for end user. It's like the crucial part which is there in Amazon and Flipkart and everywhere where you go and you just buy something which I could use at my home machine also. The other one is for the enterprise purpose. So you all have channel partners like tie-ups who actually deal for you all, or you all do a direct OEM deal with enterprises also?
No, for all our business, there are channel partners, even for consumer.
Okay.
But on enterprise, ultimately our direct customer is HP, Dell, EMC,
Yes.
Cisco,
Correct. So
or system integrators.
now the reason I'm coming to this point, wherever there is a plus one, somebody is there as a middle layer, that's where the gap comes in. Like today, what you are speaking might not be the same verbatim that I might have heard. I was just clicking snaps, when we were showcasing, because for me this is something very different. I have spent 26 years in IT, but when you go into this kind of thing, that means you all are experts in what you are doing. You said two things, when you grab that attention of mine, whether it's a memory and it's a storage. Now I'll give you an example, because even I am into the same thing. I've got one phone which has got 1 TB of storage and 12 GB of RAM. This is like 4 years old. But that was less for me. I had to add in 1.5 TB more just to handle the kind of data that I'm handling, because I have one of my colleagues who's from the content industry. So this is what we had. And then I had shortage of the memory, so I had to get one more phone by researching on my own. Again, it's not a big hi-fi, not like an Apple phone, but this is 24 GB of the RAM and 1 TB of storage again. Now, as an end user, this is just a basic research that I do, what is going to fit in me for my personal needs. As an enterprise, when we look into the data centers, now with the kind of consumption that we have, when we buy for an enterprise level any kind of a structure, whether it's a storage or the servers, it's initially what HP will give us. Not to name any OEMs, whether it's HP, Dell or anything, and they will try to sell what is best for them in two factors: the margin that they have and what they want to sell. But understanding requirement and thinking about today, I might have 1 TB of memory, which is sufficing my requirement, maybe 20, 30 TBs of storage. But in the next year, when there is more to add on, how do I size it? Then comes a part, take this off, pull this off and get something more.
Or buy a new box.
Buy a new box.
No, so completely understand. That's what I'm saying. So from our side, what we have done is, we also know that for some, there is a middle tier called system integrators. So Rohit and his team, we go out and throughout the quarter, we keep training them also. Because look, one of the challenges, who knows about it? Anybody can assemble a box. And the next round that we have started is, this kind of connect is, because we can't connect with hundreds. So at least key large organizations, we are reaching out and we are saying, look, we are willing to help. And we don't care, you buy from OEM A, B, C, how does it make a difference? You buy from Dell, you buy from HP, doesn't make a difference. But are you able to dwell into this decision and take care of it? You're right. The issue is, the people that deal with you are themselves either not educated, or they have a problem. I don't want to say it negatively, because if I was on that side, I would say my job is to sell what is in my inventory.
Correct.
That's a very business problem, and I don't want to say it in a negative manner. But when I see myself as you as a customer, I believe that you should know what is the right. You should be making choice. So by the way, we have a 96 GB product. We also have a 128 GB product. We are telling you very honestly that if you buy 128 from me, you will pay me more. But will it do the right job in your load? No.
I think saying what you're what you mentioned, just stating the facts itself is not easy. Because when you say that this is what it is, you're not trying to make money, you're trying to educate the person that what we are trying to help you to benefit.
Yeah.
For a larger audience, again, this is out of the forum I'm saying, you're talking to 15, 20 people out of a year, which can pass on to another 100, maybe 200 people further. You should also take this online on your websites, where I was asking not just for the white papers were published, you have webinars, you have forecasts, or you have content that is there, where the moment you spread this across and you start it's like a wildfire, you pass it across to 10 people, they will pass it across. This, the moment it is known, it comes from the OEMs, which makes a big difference. Today when you see NVIDIA guy coming down to India, sitting in BKC and addressing 50,000, 20,000 people come to hear him just to know what product it is. And when it comes from the OEMs and from the makers itself, trust me, it will make a big difference, Rajesh. This is a good start. I'm just saying that you have a large audience pan-India.
Okay. Very encouraging for us.
So boss is here.
Good impact. Go ahead. Speed it up.
So any other question on this? So again, from an AI standpoint perspective, that was just one from one product perspective, and now we'll see the entire SSD as well as the memory lineup as well, how it is relating from an AI data pipeline perspective. You have the entire AI pipeline, You primarily are ingesting the data, then you're transforming the data, then you're training the data, and then finally the inference stage. All these 4 stages, they have separate kind of requirement, and we have studied a lot from memory and storage perspective, what is happening from a memory and storage interfaces perspective in each of these stages. And these are pretty diverse. They are having so much different kind of requirement that we thought of creating different kind of products for this kind of line, because you know that AI is the buzzword AI, where the entire growth is happening. So much hype is there, and so much implementation is also happening. The kind of roadmaps, everything is tuned from an AI standpoint perspective, which is why we'll dwell on each of these, and we'll see from inference, transformation, training, as well as the inference standpoint perspective, what all should be required from a memory and storage perspective. Because most of the time, like initially was discussed, the discussion starts with AMD, Intel, and it stops there itself, because they are guiding you, you buy this memory, and they have no clue. But like Sir was initially saying, no negative points from them, but I have been with HP, EMC, Hitachi, and all, and in all those roles, I had no clue. I had no clue about all these memory as well as storage technologies, and from storage standpoint perspective, I thought all SSDs were SAS SSDs only, because the backend was SAS. Now the entire architecture is changing. Most of the storage architectures you would have seen, they are going to NVMe kind of backend. Back then, maybe a decade and a half back, it was all SAS. Now the entire architecture has to be revamped, just because the storage industry, NVMe SSDs are way cheaper. At that particular point in time, only 1 or 2% of storage should be on an SSD. An NVMe SSD was 10 times the cost of the SATA SSD. Nobody was looking at NVMe SSD. Today, NVMe SSDs are the cheapest, even cheaper than a SATA SSD. 5 or 7 years ago, I worked with the biggest telcos in India and moved their Ceph as well as the probe server kind of architecture from 2.4 terabyte 10K RPM hard disk drive to our SATA SSDs, which were QLC SSDs. At that point in time, Micron was the first company to launch a QLC based SATA SSD. Entirely we were able to migrate them, and it was cheaper. It was cheaper because 2.4 TB drive is being replaced by a 7.68 TB drive. Similar kind of stuff now we'll be able to do. After me, Deepak will also come, and Deepak has also experienced from an infrastructure standpoint perspective. If you want to see 2 options, in one option you have 5 petabyte kind of NVMe and 15 petabyte kind of storage in nearline SAS kind of drives, 10 terabyte or higher kind of drives. Compared to this capex, at same capex you will be able to create 20 petabyte all SSDs, all NVMe SSDs, Gen 5 NVMe SSDs. So kind of 14 gigabytes per second, that kind of drives you will be able to create. So that shift has happened in the storage industry. So your bottleneck from hard disk drive to SSDs, and once you have moved to SSDs, your bottleneck is only on memory. And that is what we'll see on all these kind of architectures. In the ingest pipeline, huge data set is there. The entire data set is being managed through Micron. You want very high capacity, you want very high power efficiency, and none of the other industry players are looking at power efficiency the way Micron is looking at it and doing so much things from a power efficiency standpoint perspective. We'll see on each of the products, and huge bandwidth also you will require in this particular state. Even from a memory standpoint perspective, you want very high capacity, a little bit on power efficiency, huge bandwidth you will be required so that you can have so much data moving in and out, and a little bit on latency. For this kind of requirement, we were able to create this 6600 IM. Initially, we will be launching it in the E3.S form factor, 122 terabyte, Gen 5 QLC NAND. This is the first QLC NAND from our portfolio perspective. The entire portfolio, once it shows up, I will be able to differentiate between the TLC as well as the QLC NAND products. And it is a 14 Gbps kind of drive. So huge workload you will be able to move from nearline SAS kind of hard disk drive to a single NVMe SSD. What performance you will get in a hard disk drive, kind of 120, 140, 200 kind of IOPS, not more than that, and not much higher bandwidth as well. Out here, huge performance jump you will get, and primarily the performance requirement is from a sequential standpoint perspective. Most of this data is sequential once you are ingesting it. That is why 14 gigabytes per second is huge. Going forward, we'll be launching E3.L form factor. In
The slide that you
E3,
showed, sorry, just to add, the slide that you showed, that is 122 TB, that's a single,
one time.
this is already in testing or?
Samples have already been there. By the end of this year, this will be out.
I don't think there is anybody else who's got this capacity, right?
Correct.
And this will be out this year?
This year. Samples are already out for this one. And for 245 TB, next year.
Single?
This is QLC. So we'll change the entire landscape. So the way I was able to talk 5-7 years ago with all the top 2 telcos that you can now move from 2.4 TB hard disk drive to an SATA SSD, and it is cheaper. By the way, because faster, smaller, we don't have anything moving, no mechanical fault, everything was any which way is good for us. Only
That is another problem. We are already sampling that 122 TB. And this is a problem that, when we are coming into this discussion like this, we scratch our head saying, if we don't tell you that 122 is in the pipeline, suppose you are planning a data center architecture today and you are to take a decision in the next 30 days. In absence of that,
So that was the reason why I asked, because we just upscaled something. And I'm just thinking, like, when I added up the 2 TB drives also into X count, if this is coming up, even that 122 or 100 plus in a single disk, apart from the costing, how much of sizing and everything can be saved?
huge. 88 petabytes you'll be able to go up with this 6600 iron drives. So kind of 20 drives in a 1U kind of. And once the 245 TB comes in, this will become 140 petabyte
It all
in one
depends
rack.
upon your rate group and the usable capacity as well.
So this is raw.
Yeah.
This is all.
So when you calculate the usable capacity and with rate group and all,
Correct.
you need to find it out, okay, what will be the right proportions.
Correct. So again, from a rate 5 standpoint perspective or eraser coding perspective, you can shave off some 20-30% out of that.
Not that having a higher capacity would be great in many cases. It all depends. Not that higher capacity would be great, okay, so it all depends on what kind of your rate group you're going to build it and what.
Correct. So if I take an application example, Ceph has a guideline, even way back it had a guideline that in case you are creating a Red Hat Ceph storage and you are using hard disk drive, you should have 3 copies. In case you are doing it on SSDs, you should have only 2 copies. So any which ways, while moving from SSDs to this, you are at least saving on 30% off as per the application recommendation as well. And from a server standpoint perspective as well, once you are moving from a hard disk drive to SSD, 2U rack server, same 2U rack server can mostly have 10 or 12 hard disk drives, which are nearline SAS, 10 TB or higher kind of drives. No? While 24 drives U.2 or U.3, you can right now only fit in. And the newer age kind of devices, this EDSFF form factor, this you can fit in 1U also 20 drives you can fit in. So discount that. Even right now, you can have U.2 or U.3 kind of drives, 2U rack server, 24 kind of drives. If E3.S is supported in those kind of servers, then you can have 40, 32 or 36 depending upon your vendor. Supermicro has 40, others have 36 HP, and the leading players also 32 or 36 you will be able to get to if you are using E3.S kind of form factor. So that way, huge capacity. Now, once you are moving from this kind of architecture to this, your overall TCO is lower. Drive to drive cost, the dollar per terabyte on hard disk drive versus dollar per terabyte on SSD will be 5 times, 4 to 5 times, 3 times, depending upon what we are comparing. But your overall TCO from a server standpoint perspective will be still lower out here. Why? Because the number of servers itself gets reduced. So many less servers you require out here, so many petabytes you will be able to scale up to. This kind of capacity, how can you grow from hard disk drive standpoint perspective? You will save on processor cost and memory cost. Because the same, maybe 10 servers will be able to do the job earlier 40 or 50 servers were doing for you. And that way you will be able to save on processor and memory cost of the cut down servers, maybe 40 servers. That's how you will be able to fund the move from hard disk drive to an SSD. This, we have already done that. Deepak will be highlighting in his presentation as well. And we can also work with you. You bring out your case for a Recent case, the case that I just discussed with you, 20 petabyte, 5 petabyte on NVMe, 15 petabyte on hard disk drive, 20 petabyte on SSDs, and that to Gen 5 NVMe SSDs. Gen 3 NVMe, double the performance with Gen 4 NVMe, again double the performance with Gen 5 NVMe. That is what we are doing, 14 gigabytes per second. And 4 terabyte RDIMM for this kind of architecture you will be able to do. With this 67% more rack density, you will be able to go with E3.S drive compared to U.2 drive and 37% less energy. So not just on capex, even on opex you will be able to save. So this is just for ingest. Any question?
So I think data tiering is an essential part. I think I'm sure you will
Correct.
cover that also, right? Because the transformation from hard disk to SSD.
SSD is there.
Yeah.
Correct.
But how to tire?
Correct.
That
So there are two kind of approaches that you could take. Either if you want to do an tiering, you can have a higher performing tier on top, or possibly you can do entirely with the 6600 kind of, or the right now what is there, 60 terabyte TLC SSDs are already there. We have launched them several months back. It is being deployed in so many data centers. So 60 terabyte Gen 5 NVMe SSD, again giving you 12 or 14 gigabytes per second is a huge number. So possibly all the performance that you were getting any which ways from a hard disk drive, you might be able to do that same with by replacing those 10 TB kind of or 16 or 20 TB kind of hard disk drive with a 60 TB TLC drive right now as well. And once this comes in, again that gives a big jump and you'll be able to cut down on much more servers count as well. So again, we'll be able to work with you once we have that particular use case. Whether you actually require a tiering or not, there are drives. Just because we are discussing the AI use case and this is for ingest, but the entire portfolio is there. We have performance-centric SSDs, we have capacity-centric SSDs, and something in between the semiconductor industry calls as mainstream SSDs. So a bit of both. So all three kind of SSDs are there. Swim lanes, so to say, are there available.
Just a quick one. Apart from the storage capacity that you're saying, which has increased or which will be increased drastically, what about the span, the lifespan, in terms of the read write, every storage unit will have a span, whether it's for 1 year, 3 years and so on, whether it's Seagate or other products also there. So in terms of Micron, how do we calculate that, and is the standard going to get improvised, or is it going to be how it is currently in terms of the life of the disk, of the storage?
Correct. So there are two standards from a semiconductor industry perspective. One is this kind of drive which is very capacity oriented. In this we typically are offering 1 drive write per day for sequential workload. For a random kind of workload it will become almost 0.2 or 0.3 drive write per day from an endurance standpoint perspective. But generally in ingest or in AI kind of workload or wherever files are there, all this workload is sequential. Even logging for that matter is sequential. Generally this is not meant for databases. Only out there you will be requiring random kind of 4K kind of block IO, which is why there primarily you require very high endurance, for which the semiconductor industry has two kind of drives, 1 drive rate per day and 3 drive rate per day. So those are high endurance, and all these drives we are offering for 5-year warranty, even this one.
So when you say 5 years warranty, okay, in simple layman's term, if you have to explain somebody that how many times they will be able to read, write, copy, delete, whatever they do. So in terms of count, you must have definitely counted per day it's 1 or 3 that you're saying. So in 5 years total, how many times total that you're taking in term that case?
I'll just give an example. For example, right now we have already launched and it is already working in data center, 60 terabyte, 6550 iron SSD. That you can go up to almost 1 drive write per day with a sequential kind of workload, and mostly all these workloads are sequential only. Generally there is no random kind of workload in this kind of scenario, and in petabytes kind of scenario. In that we can say that 60 terabyte drive, you are getting 1 drive write per day, means every day you will be able to write 60 terabyte on that particular drive. Every next day you will delete entirely and you will write new 60 terabyte, and you can keep on doing this for 5 years. 5 year day 1, 5 year plus 1 day, the drive becomes read only. That is the endurance of the drive. It's huge number. So some 7-8 years back, I had the similar kind of discussion from an endurance perspective, and the semiconductor industry also calls it endurance anxiety, which typically is there from an industry standpoint perspective, and customers are not able to migrate from hard disk drive to an SSD. Why? Because the drive might die. It is an endurance issue, and hard disk drive, the best kind of hard disk drive that are there, they will give you 550 terabytes per year kind of write. Beyond that, they cannot write. They will also fail. So that is the max that they can do. While out here, they are giving you petabytes kind of number. That is why our one drive write per day is a huge number now, 60 terabyte, right? Every day you can write 60 terabyte of sequential data. It's a huge number compared to 550 TB per year of hard disk drive. So we are much more resilient than a hard disk drive. It's just that it's not discussed, and the endurance anxiety is there, and again, not debated out. So it is much more reliable drive, and from an AFR perspective as well, typically a hard disk drive will have 6 to 8% AFR, while our annual failure rate is just 0.2%. Semiconductors, not just Micron, entire. So that is from an ingest standpoint perspective. This is the entire roadmap that we have. Every year you will be able to see we're doubling the capacity. That is why we will be able to catch up with hard disk drive again. How many bits we are able to create as an industry standpoint perspective, that only is a question. But if you want to move your data entirely from hard disk drive to SSD, that would be possible at a lower TCO as well, much higher performance, much lower power consumption as well. 6500 and 6550, we were at a TLC level. Why? Because Micron has taken a stand different than the entire industry as well as the analysts what they stated, that QLC will come later on. At this point in time, most of the customer, even from a large organization perspective, a private cloud might be created, and within your company as well, you might have other customers, and your data could be unknown data to you. You do not know what sort of profile that data might have, and upon years the requirements could change as well, which is why you do not know whether a QLC drive will fit or not, which is why Micron has taken a standard. At this point in time, 6500 and 6550 are already out there in the market, and they are all TLC. So from a endurance standpoint perspective, you don't have that much challenge, and from a power consumption perspective as well, they are much better, and they don't get too much heated as well compared to a TLC and a usual QLC NAND challenge. That also is not there. Later on, we will, because the market is moving towards that, and now we have to go after that hard disk drive space, which is why we are moving to QLC, and later on you will see cloud storage optimized NAND being developed by Micron. Again, our workload engineering team is working, and that specialized NAND, again it is QLC. QLC was developed way back, but because we were not able to make it economical and we were not able to create it for all sort of workloads, which is why we delayed the launch actually, which is why all TLC till this point. And now QLC will come in. All that QLC will be optimized for the kind of cloud storage workloads. Then moving on to the transformation layer, the entire workload characteristics changed. They have got almost inverted. Out here, IOPS also matter now at ingest stage kind of, because you'll have very small reads and writes and multiple. You might be doing a lot of things to those data that you have ingested now, and that dedupe might happen. You might transform it to some other format, and then you'll filter it, label it. Again, metadata might come into picture, which is all small block sizes, which is why IOPS matter, latency matter a lot, bandwidth definitely will matter. Again, from a memory standpoint perspective as well, lot more capacity will be required to feed this data in and out quickly. Your data should be in memory so that you are able to transform it quickly. All this profile level, we have launched our mainstream SSD, the 3 swim lanes that I talked about: performance NVMe SSD, capacity NVMe, and this is the in between, mainstream NVMe SSD. This is again on our Gen 9 TLC NAND. The entire portfolio, now we have moved to the Gen 9 TLC NAND. It is again a Gen 5 NVMe SSD, and a huge jump we have done from a QoS perspective. 6 nines, that kind of performance we are able to give. This is pretty much similar to your usual IT workload that you have always been doing from a database perspective, similar to that only. And random writes of almost 400 k IOPS we are able to deliver in this. Any question on this? Then on this particular stage itself, you will require much higher capacity. So whatever whatever capacity in RDIMS you are able to get in a 2U rack server, you have 24 slots or 32 slots, all that you will be able to create using your usual RDIMS. In case you want higher capacity than that, or possibly you are looking for a high frequency trading or any other application which is latency sensitive, and you want to cut down on latency as far as possible from a memory standpoint perspective, then we have introduced what is called as MRDIM or Mr. DIM, you can say. It is an improved version. On the same architecture it will sit in. Only challenge right now is that Intel only is supporting it. It has been co-developed with Intel, and from Venice onwards only possibly it will come with AMD. That is the plan at this particular point in time. But in case you are on Intel Xeon 6 Grand Rapids architecture, then this is already certified. This is same from a fitting perspective, electrical connection, everything perspective. Pinouts is same between this RDIM and this one. There are two form factors, the small form factor and the tall form factor, what we call as. This is exactly same. The other one is only taller. Everything else is pin compatible. On the same Intel Xeon 6 Grand Rapids architecture server, you will be able to use an MRDIM. The advantage that you now get are highlighted in this particular slide. 40% higher bandwidth you will be able to go up to. 40% lower latency almost you will be able to get with this kind of architecture, and you can increase the capacity. What is MRDIM? Multiplexed rank DIM. So essentially these are two DIMs in one package. So why these are 8800 speed gate? Because there are two 4400 speed gates at this point in time. So at this point in time right now, 6400 speed gate is the usual standard speed gate that is being used across the industry, and we have already launched 8000 speed gate as well. But at this point in time only this goes up to 8800 speed gate. The next bump will be from MRDIM perspective at 12800. Similar to from DRAM to LP kind of jump you will be able to see. This you will be able to utilize so that the same from a transformation perspective, a lot of customers use Apache Spark AI SVM, and that you will be able to complete 1.7 times faster and 1.2 times better system energy efficiency you will be able to get with this kind of architecture, which is why you should move to this particular. Whenever you require very high capacity of DRAM in memory databases or AI kind of workloads, all those scenarios you can go there, or high frequency trading when latency is of utmost importance. This has 40% lower latency and much more pronounced in a loaded kind of scenario wherein you are actually driving the DRAM at its maximum level possible. For example, 600 gigabytes per second is the limit. You are driving to that levels only. That's where you will be able to use this MRDIMS, and then usual mainstream SSD 7600. All the advantages from power, performance as well as QoS perspective. Then the last one, training and inference. Again, this is a stage wherein all the IO profiles are maxed out. You want almost a bit of everything, a little bit storage capacity. Other than that, possibly you want whatever best is possible, whatever highest level is possible, which is why we will be launching next year our 9650, which is Gen 6 NVMe SSD, 28 gigabytes per second. Right now, our mainstream highest performing 9550 predecessor to this SSD goes up to almost 14 gigabytes per second. Because it is Gen 6, it will double that, 28 gigabytes per second. And the kind of IOPS you can see, 5.5 million IOPS, 900K random write IOPS, random read work 5.5 billion. That's the kind of profile we'll be able to create with this 9650, primarily for training as well as inference kind of workload. And this is the drive because liquid cooled environment has already been there for GPUs, CPUs, all even memory as well. It has propagated to only for SSDs but not there, and this will be the first one that will be compatible, and that is why we are coming up with the 9.5 mm size. So it is liquid cooled compatible. Then because we are talking about inference, and inference is not there just in the data center, it is also there in the edge side. even from a data center side perspective, it is all running on the GPUs, and kudos to NVIDIA, which has a huge bump that they have given. Almost in last few years, they have almost given 37x much higher performance. They have consistently developed and they have challenged Micron big time, and we have responded back, and that is why you see all the kind of GB200 that had a HBM 3 8 high stack, then GB300 that has our HBM3 12 high stack, 36 gigabyte kind of modules, and the next one that we will be launching would be HBM4. This will take the journey to the next level. That is why we will be able to enable NVIDIA to get to much higher performances from 1.2 terabytes per second in HBM3, the current standard GB200 300 will go to 2 terabytes per second. That is the kind of advantage we will give to the GPUs, and from 1024 to 2048 bits and much higher performance per watt as well we will be able to give. And again, from a self-testing perspective as well, that QS will already be built in. Any question on this? This is the roadmap. HBM3 is already there, it is out there in the market, and HBM4 will come in next year. And this is the entire storage portfolio being mapped to an AI kind of workload, right? From capture ingest perspective, you have very high capacity drives or the capacity tier SSDs. Then training and inference from a performance standpoint perspective, the highest performing drives, and then the mainstream drives primarily used in the transform kind of workload or your usual current data center kind of standards perspective, or similar to that kind of workload. The entire presentation was only focused on AI because the theme of the event was AI. But whatever workload you can think of, for that we have our data center workload engineering team. They have done all that testing, and any other kind of workload, Cassandra or Vector or MSpace, Ceph kind of workload. All these have different kind of profiles, which is why different kind of reads and writes is there. Some would be random oriented, some would be sequential oriented, some will have small block size, some will have large block size. Similar to the kind of requirement, we have different kind of endurances as well. So all the capacity oriented drives, those are at best 1 drive write per day for sequential workload. For random kind of workload, which generally they are never used, that is 0.2 or 0.3 drive write per day. All the other kind of drives typically are 1 drive write per day or 3 drive write per day. Whether you are talking about the mainstream NVMe SSD or the performance NVMe SSD, performance or mainstream, generally they will have 1 or 3 drive write per day. Only the capacity oriented like 6550 currently and soon to come 6600 series, all those IN series, they are less than 1 drive write per day, but for sequential workload it is 1 drive write per day, and it is written in our data sheets. Micron was the first company from semiconductor industry standpoint perspective, which in their data sheet started writing what is your endurance in random workload and what is on sequential workload, because it takes a huge test efforts, time energy effort to calculate the kind of endurance you will be actually getting in a sequential kind of workload or in a random kind of workload, and we are publishing both the numbers, and most of this kind of requirement they are all sequential, which is why 1 drive write per day we are able to get and written on the data sheets. So that's it. This is how we'll be able to help you in case you are architecting and you want to partner in that journey as well. Whether you are talking to a tier 1 kind of OEM or a tier 2 kind of server OEM, the only difference is typically the configuration is from a memory and storage perspective is blocked by tier 1 server OEMs. All tier 2 server OEMs, they typically allow you to do whatever you want from a memory and storage perspective. We work with the entire ecosystem, with the compute vendors as well, all the SIs, ODMs, EMS players, and from a differentiation standpoint perspective, there are so many different products that we have carved out compared to the industry that we'll be able to share with you, and you'll be able to use in your particular kind of scenario. And if you want to create any custom solution, then we'll be able to help you. Sampling also will be able to help you. Supply and project pricing perspective will be able to help you. And this is what initially was Rajesh was highlighting. Although we are commodity, but in case you are actually talking about a large use case, it is a storage centric kind of configuration, then 70% of the BOM is controlled by Micron, SSDs and DRAM. Generally 20-25% only is processor. Rest is just 5%. The leftover paraphernalia in the
Totally
server.
paradigm shift.
Yeah, 90%.
So far, we realized that 70% of the BOM is to be on CPU.
Correct. And most of the discussions only are on their CPU. I was not talking about GPUs. If GPUs are there, definitely this number will come down because GPUs any which ways are way costlier. But if we segregate the GPU out, then this is the number. And to utilize those GPUs, you will require these kind of drives. So that, I mean, whatever architecture you have one-to-one mapping between GPU and the SSDs, or you have single SSDs bounding multiple GPUs. In all those kind of architectures, you should be able to utilize all these kind of drives. And the next speaker after me, Deepak, he'll be able to highlight on the entire tiering and the architecture, because I shifted to the semiconductor industry primarily when I saw that, and the other colleagues that I had seen in, they were seeing the change from an enterprise class architecture, which is you have server, SAN switch, and a SAN storage, or maybe a NAS or a CAS kind of storage. This moving to a server SAN kind of architecture, because in case you want to go to 20, 30, 50 kind of petabytes kind of requirement, there is no way you can build that same solution with the usual SAN storages, NAS storages, or CAS storages. Typically, you'll have to go to a software-defined storage, maybe Ceph or VMware vSAN or whatsoever. That software-defined storage, Deepak will be able to cover. Deepak is country director for Space, and we are closely working in several opportunities. And the kind of example that I initially gave, 5 petabyte plus 15 petabyte, 5 petabyte only NVMe, and then on hard disk drive. Similar to that, CapEx you'll be able to create on 20 petabyte NVMe. That Deepak will be able to highlight. Over to you, Deepak.
Can you hear me on the mic?
Yes.
Perfect, thank you so much. Thanks, Rajesh and Rohit and the Micron team for the opportunity to present about Space. I just want to ask around the room, before you walked in here, how many of you have heard of Space? Great, perfect. I was not surprised. In fact, Rajesh mentioned that Micron being a company of long history, they took a long time to come to India. But when they came to India, it was a massive scale and massive growth, right, from 2019 to what's today. Space was born in 2019, so very new to the market. So, I won't be surprised at all, right? What I'm going to talk about today is about data, right? You've seen a lot about amazing storage technology, memory technology that is built specifically for various stages of AI pipeline. But what really runs AI? It's a data, right? How do you make the data a strategy in your AI use cases, AI pipeline? And what are those metrics that matter? And the question is, can I apply one method that can really make my strategy feasible where all my data is? That's what I'm going to talk about. But before I just get to the topic, one thing that I like to mention out here is when we think of AI, right? We sometimes think of massive data centers that are running large language models, training, inferencing. But at the same time, AI is also running a lot in the cloud. There's edge where the AI is building reserves, or we call the actionable decisions that happen out there. So from a data perspective, data strategy perspective, you have to think of data where the data actually resides. So today, what's happening is that while we have heard of real estate, where we own a property, we own a house, there is something called as data estate, where the data lives, right? And bringing a strategy across all this data estates into a single source and pipeline is what really defines how AI is going to become a successful strategy for you. So data strategy is one of the important aspects that really need to matter. Okay, so it's a data center, it's cloud, it's edge. But within a data center, it's not one storage tech. There could be many different storage technology that are out there. and each of them can be a silo. Now every OEM is a silo of its own. Now imagine you have a multi-vendor OEM data center. Cloud are different cloud vendors, have their own technologies. Edge, boom, countless, right? Now imagine you have the data that is to flow across all of this. How do you make it feasible? Hammerspace, we were born when the data started realizing its potential and its value. And our team felt that if we don't build a strategy or a solution that can define a data strategy, a lot of AI projects will never take off. And let's think of what we can make that possibility. So what I'm going to do is that I'm going to quickly touch upon 3 important AI systems and what are the data strategy that applies to these systems. Look at what's similar and what's difference between them, and then let's look at bringing it all together in the industry, and that's what make it feasible out there. Okay. With that, let's look at the first AI system, generative AI. We all know this, we use it every day. So what is generative AI? It is that AI system that creates new content by simple human inputs, right? Text to speech, text to audio, text to video. Basically, this system generates text, audio, video, can create codes, learning patterns from massive data sets. So this technology predominantly powers ChatGPT, DALL-E, DeepSeek. These are these technology and tools that give human creativity what you need to create as a new content. Generative AI thrives on massive data. Today, if you look at generative AI, where is this data actually residing? In data centers where the training of these models are done, the llamas, the GPTs, the DeepSeek, have their own training. While large part of the training is done in the data centers, cloud is also one important aspect of the data strategy. The remodeling or fine-tuning of the data happens a lot in the cloud. But in generative AI, edge has a very, very minimal role to play. So the strategy of data or data resides or data estate in generative AI is massive data centers and the cloud. Okay, so that is one aspect of generative AI. Now, when we shift from generative AI to agentic AI, we are actually transforming from generating content to taking actions on it. These are your autonomous software-based agents that can plan, it can reason, and it can perform very, very complex tasks that humans do with minimal intervention from human side. Right? So when we look at agentic AI, in agentic AI, where is a workflow of data? Training, of course the agents have to be trained, the data centers. The remodeling, fine-tuning, cloud, absolutely yes. But where do you really apply it? At the edge. Because that's where you do take the decisions, the inferencing happens out there. So the data that is processed has to be trained to model and to be applied out there. So all the 3 aspects of the data estate come into play. Physical AI. Now this is what comes alive. This is where AI becomes real aspect or real things in the world. What we call it coming alive, right? The science fiction movies that we see, the Terminators and various others, right? So the physical AI, basically what I would say, the collaborative robots, the self-driving cars, the smart, manufacturing systems that are output of an AI factory. These are the ones we really, are going to be the future that we are going to, walk into. Now, if you look at physical AI, the data strategy or data estates are very, very similar to agentic AI, with one difference. The intensity of data movement between the 3 estates are extremely fast and extremely high. Why is it so? And why is it different? Because the training and inferencing, and the modeling can happen in the data center and the cloud, but the robots and the systems or smart systems are the edges. But while they are using the data to take the actual insights and actual decisions, they also are fitted with a lot of sensors, lidars, data capture system, data accuracy system that are not only using it to take the decision, but that feed the data back to the data centers where it can read and remodel in real time. So now imagine A flow of data which was one way now has become mixed ways in different directions. So why I'm saying this and why is it important to consider today? This is because a lot of technologies have created silos, and moving data around to make it feasible has become a little impractical. And Hammerspace is one company who thought about it and said, we have enough more partners who build technology and storage. Why don't we look at the data and make the data, mobilize itself across the various storage systems, irrespective of storage, and make it feasible for an AI pipeline to work seamlessly. That is what strategy we thought as a company, and now we have become one of the pioneers in this direction of building data strategy for industries and customers to find their ways and means around building their AI strategy. So basically, when you look at AI is not going to run in one place, it's going to run everywhere. And that's the future that we're going to go into. So you have to think of your data where I can run AI, the data should be there. So it should be, the data should be there at the right place at the right time. Imagine you've got very massive data center, but your data is somewhere else. What do? You have to do a large amount of copy. And that copying data, you lose a lot of it. But what if I could just access it instantly? Sounds science fiction, right? Let me tell you, Hammerspace is very possible. We make this data accessible instantly, even if the compute and the data are separated by a huge geographical distance. And we found an innovative method to be able to do that. And we don't do it by copying data, but we do it by managing metadata. If I know the metadata, I know where the data is. So we created a very intelligent metadata system that can give access to the data irrespective of the distance where the data is, and bring it quickly to the system with the training, inferencing, and edge computing, and can apply it. So why is it important today? Because the chaos of data estate, of silos are more than 80-85% of the AI projects are a non-starter or a failure because they have not been applied with the right data strategy to the right AI outcomes that they want to achieve over here. It's not because they cannot access the data. It is accessible, but it's not accessible at the right time, at the right place. That is the bottleneck. That's a problem. And this is what we want to address. So for example, if you look at an AI factory model, this is an example of NVIDIA. Like you will have a similar model from AMD, from Intel, who are building AI system, right? They have created a very comprehensive stack which has a complete blueprint of the various software layers, the GPU orchestration layer, infrastructure management layer, and they just say one thing: storage. Why did they say that? That is the strategy of each one of you who want to apply this blueprint. Now you have to find the strategy for your organization, for your industry to make it feasible out here. Okay. Now imagine that if you take this blueprint and apply it to today's chaotic state of data, what do you get to see? Something like this. You want your AI pipeline. Some data are locked in some proprietary storage system in data centers. Some are in the edge, some are in the clouds, or put in multiple clouds. Imagine you have to migrate data to make it available by creating copies. You are not going to get your actionable insights the way you want to get it. And this is where a lot of the AI projects are not able to get the right starters. This is a problem we want to solve with Hammerspace software. So, if you were to look at data as a strategy, you have to create your own data blueprint strategy in addition to the AI blueprint that the AI companies are offering you. Because they say, yes, AI blueprint is ours, but data is yours. You have to build the strategy for the data. And technology like ours is the one which is becoming the partner for you to define the strategy for the data. Right? So what if we could do something like this? Let's start afresh and think it like a world. Okay, I'm just taking you through a world, something like a science fiction. What if we could build a global file system which could bring all my data sources, irrespective of the vendor that is built the storage system, irrespective of the data center where it is residing, irrespective of the cloud, irrespective of the edge, into a single visible namespace. That means a GPU system running the data center can instantly set the data on the edge and vice versa. It's visual thinking, right? Let's go further down. What if I could get easy access and visibility of data as and when I need it? What if I can build an autonomous pipeline that is not restricted to where my data is in the data center, but a pipeline that can span data center, cloud, and the edge, so that I'm able to train, model, inference, get the results out instantly. That means I'm not waiting for data to incorporate around. I'm going to run my pipeline and let the data come to the compute system on a very intelligent manner. Right? See, this is some of the visual thinking that a lot of industries like to have. And to make this possible, we built Hammerspace. This industry's first, I would say, data platform for AI anywhere. How we made it possible is that we created a software-defined platform that can abstract data from all your storage system, be it in multi-vendor storage, multi-cloud, or multi-edge, into a single namespace. Now, all this data, which were represented by different metadata, has one metadata, or global metadata. From that global metadata, any system which is running in the data center, in the cloud, or in the edge, now can see the entire data visible for it. So you can run your training, inferencing, remodeling anytime you want without worrying about where the data is. Run the workload. Hammerspace will use this intelligent metadata function to bring the data to the system in a seamless manner. So you have broken the boundaries of data estate to create a global namespace. So in the nutshell, Hammerspace is industry's first global data platform, making these functionalities possible. 5 years back, if somebody had told, is it possible? I would have told, no, it's not possible. But why it is not possible? Because a lot of storage vendors focused on solving storage problems. We looked at how to solve a data problem. And data problem could not be solved till you did not know how a metadata refers to a data, or what is a metadata. If you can control the metadata, you can control the data. That's how the idea of Hammerspace came into being. So with Hammerspace, it's a parallel file system built on industry standards, nothing proprietary. Everything is underlying Linux. You have Linux, it just builds itself. It uses a method called data assimilation. It can sit on multi-vendor storage system, assimilate all the metadata into global metadata. Now let's say you have a bunch of NetApp storage, you have a bunch of Pure storage, bunch of EMC storage, all of them their own metadata. Now each metadata represents that island of storage. What Hammerspace can do, assimilate all this metadata from multi-vendor into single global metadata. Now, a single global metadata will know where the actual data are, irrespective of storage vendor's system that's out there. Now, that's what AI makes it possible. Yes, Rajesh?
But where will that sit? It will sit on the existing hardware, or?
Yeah. So I'll show that. My last slide is on that part. Where do you consume Hammerspace? How do you make Hammerspace a part of your data strategy? I'll touch upon that. Okay. So this is one important aspect, because what we do is that we're not touching the data. We are abstracting the metadata. So imagine what VMware did many years ago when physical server needed, every application needed one physical server. VMware abstracted it, decoupled it, and made that application into a VM, and then controlled it through a control plane called vCenter. vCenter became the metadata of the compute plane. So Hammerspace is doing exactly that. When we assimilate, we create a metadata layer, which is vCenter, which can control the data plane irrespective of where the data sits on any independent or third-party storage system. Now we can be in a data center, cloud, anywhere, it doesn't matter. Okay? So the idea is to move from a storage-centric management to a data-centric management. Focus on the data. Let storage become the underlying physical data plane that sits over there. Okay? And finally, the idea of data, to me, be at the right place, right time, is not data collaboration. It's called data orchestration, data mobility. I'll give you an example. Let's say you have done a fair amount of training, and that training has been done on, say, a data set of 1,000 files. Simple example. Okay, but for inferencing, I had to inference only on the 100 files out of the 1,000. Let's say you have to do the inference in the edge. How you bring the data if you use migration? You migrate 1,000 files, do the inferencing on the 100 files, and then after you do the inferencing, you resend the state back. But when you do data orchestration, data mobility, you know what you do? You don't migrate 1,000 files. you make that 100 files instantly available to a remote system to operate on it, still keeping the files in the same location where it is. Because a metadata will tell you, these are the files and you operate on top of that. So data mobility and data orchestration makes that intelligent decisions that help AI systems and global workflows work very, very seamlessly. These are some of the intelligence that we got into a software-defined platform. Okay, so now imagine applying the same blueprint of AI factory on a Hammerspace provided data-centric approach versus a story-centric approach earlier. You do not have to worry about where your data is. You run your blueprint, the strategy of data that has to be applied is seamlessly brought out and fed into this system, which is now a global AI pipeline, irrespective of any physical boundary that's out there. So Hammerspace today makes AI possible, the reality is no more science fiction. What you wish for is possible today you make it. Be the data in various states, it doesn't matter. Be it in a kind of an NVMe storage of any, it can be hard drive storage, it can be cloud, it doesn't matter. We are able to abstract everything and then place it in the right placement so that the right actions and decisions can be taken on the data from a pipeline perspective. Right? Oops. So what is the data platform AI all about? It's all about simplification. Get the metadata in control to know where your data is. Save thousands of hours of migrating data across real estate and create a single visible area and run your workload. Focus on the workloads, focus on and let Hammerspace take care of getting the data to be able to automate it. Now your automation is just one layer. You're not doing migration. You're saying, I want to write a program and automate the data so that I don't need to migrate 10,000 files to get 100 files. I just automate the 100 files. So we give a lot of automation by giving it to from a namespace. And finally, what AI system requires is absolute acceleration. If you are able to accelerate, you are able to get token efficiency, a faster time to first token, and bring in an overall experience. This is where your AI systems become more real. And from a strategy perspective, you do not fail. You are able to build the strategy that can make AI work seamlessly. So, from a deployment perspective, the question which Rajesh asked, how to deploy Hammerspace? Where is it actually run? Okay. So, in our go-to-market, we are a software-defined storage. We just give a software. Now, this software can be built on any industry standard servers. So, we just require servers, Intel, AMD, Micron memory, Micron SSD, all the beautiful technology what Rohit spoke about. We leverage all that, and that becomes our storage layer, and we sit on that and create that into a data platform. So our go-to-market till recently has been to purely give as a software and let you choose your own hardware. And as from Rohit's point, if I were to look at getting into right details of having the right storage technology, allow you to have Hammerspace, leverage and build that into a data strategy. We've always been in the cloud marketplace, all the cloud. So what exactly you do in your data center, you're able to do in the cloud and bring both this together into a single global namespace. One demand that we got a lot from a lot of enterprises is that, hey, can you give me something that is on reference architecture so that I can standardize it? But I want still it to be on industry standard. So we started working with Supermicro, Dell, Lenovo, Hitachi, Cisco. And now what we do is that through them, we are creating what we call as standard SKUs that they can give. But inside the SKU, it is still the same its architecture. The Micron's memory technology, Micron's various NVMe technology, everything that goes into that. But packaged by OEMs so that some of the enterprises who need of standardism of those OEMs, they can get for the support and other operational models that they build can go seamlessly. So we keep all the three approaches. Just to address your point, Rajesh, these are the three approaches that we have. This two are already in place. This is something that we have initiated recently. We already launched it with Supermicro. I think by beginning of next calendar year, we have an announcement going in Dell. We are working with Hitachi. So we are an evolving company. We have started working on it and we're getting a lot of partnership. And today we are becoming that important software that is defining the data strategy for enterprises, service providers, industries to really get AI into action and get the results that you want to get out of it. Okay. I'll just take a pause here because I know if I proceed, I may be, disturbing the fun that you're coming here for. I have a lot of things, but I don't want to do that.
What is the last one? MSP is branded into edge?
Yeah, it's a good question. This is where we are working with players like Avnet to create a Hammerspace branded, appliance.
Right.
And there's a reason why behind it. Now, being in the AI industry, some of the big players require that we have to be certified, like NVIDIA. Like you have the base pod certification, super pod certification, NCP certification. Under the certification, they define that to be certified as a storage or a data layer, you have to come as a single vendor appliance. If you ask me, that is not our sales strategy. That is to align with some of the major players' requirements to be certified. So yes, we started working with Avnet, and with Avnet we are creating an appliance. So it's basically another commoditized industry standard server, but just a Hammerspace, base, with the name, that can go through. So I'll take a pause here, and I will not take much time. Probably in the discussion I can touch on some of the very interesting things that we do. But I think this was overall thing that I want to present about Hammerspace as a company.
Thank you.
Any questions? Any thoughts?
We work with Government of India, they, like Aadhaar or voting list, or they have very large storage and
Yeah.
database.
So we are today working jointly with Micron to address some of the requirements in the government public sector. What we're doing is that Micron has the right storage technology, right? But government of India requires something around related to India. We call it Make in India. So what we do is that we are partnering with a Make in India OEM player to, like this only building a reference architecture globally. We are creating an India-centric reference architecture. So now that reference architecture can become a reference architecture with Make in India. Now with that, we can take the government media and present it into their digital initiative or digital study or called AI in India initiative. It's a work in progress. We just got things started. Maybe by end of this calendar year, we'll be releasing the unfortunately I cannot reveal the name of the vendor because it's an under NDA. But once we start testing, we will be presenting it. I just want to touch upon one point which Rohit mentioned about an exercise with. This is one of the large public sector company told us that, hey, I want 20 petabytes of storage that is going to be running massive parallel data operations. Can you give me a solution? But my requirement is I want 5 petabyte in NVMe and 15 petabyte on hard drives. So as we are dividing the hard drives, he said hard drives are cheaper. Okay, fair enough. Let's try and put an exercise. You know what we did? We gave them a configuration in an as-is model they asked. Alternatively, what we did was that instead of taking hard drive, what if I take the entire 20 petabyte only using Micron's high density 61.4, which is these are 6550 ion drives, right? You know what we discovered? The capital expenditure of both this are the same. That means there's no price difference. Somebody might think that, hey, if I'm doing 20 petabyte in NVMe versus tiering, will the NVMe be costly? And I personally thought it might be costly. But when we put it together, it was same. But then what was the real benefit we saw? 90% reduction. Racks, power, cooling, and management and operations. 90%. I'll give an example. To get 20 megabyte, okay, it required about 3,600 hard drives, which constituted about 15 petabytes. You know how much that was coming in Micron? 368. See, from 3,600 to 368, it's a huge reduction. Imagine the amount of real estate reduction that you've done out here. So 90% is significant. Now for the customer, that has become an eye-opener. Of course, being in government, they will always evaluate from different lens because they want to ensure that if there is a tender around this, it doesn't go through a monopolistic thing. They evaluate, but they've taken it very seriously that yes, I believe this value is, but let me not figure it out through my commercial option. But I just want to highlight this that yes, large capacity of storage requirements can very well effectively met by high density NVMe drives at a much lower cost than what was possible earlier. So just wanted to share that. And this encouraged me to look at more and more options to if it's an enterprise, Rohit, I would not even recommend the option. No way out of it. Because that's a business case, a business setting that we can do. And the government, of course, they have to look at the policies, what they have, they cannot a single vendor control everything. They should have different vendors being able to participate. But what they're doing now is they're going back and asking all the vendors, hey, can you give me 6 to 1 terabyte drives in your portfolio, because that is becoming more safe. So they started inquiring, with them. Right? Thank you so much. Thanks for your attention. Thanks for your time.
Thanks, Deepak. Last few minutes, what we'll do is we'll do a small exercise. You all will be given sheets, and you'll have 2 sheets, I think. There will be a QR code there. Can we just also show this QR code on the screen, please? What I want you to do is just take out your phones and scan that QR code. I noticed you started filling up the form already, but please scan the QR code. It's there on the screen, it's there in front of you also on the sheets. Because whatever kind of you heard today, I think some of you found it very interesting also, and quite a few interesting insights, right? I mean, 88 petabytes in a 1U rack, that's amazing. And the kind of performance and all the things that I initially talked about, it's all actually coming true, right? Power efficiency, more capacity, more performance, a lot of insights, and I saw you asking questions. But now is the time actually, which is why I wanted to run this now, so that your perspective might change on some of the things that I'm asking. So you all managed to scan the QR code? Have you got a screen in front of you?
Yeah.
You all got it?
Yeah.
Okay. Can you move to the next screen, please? Because I'm not able to do it from here. Okay. So basically the idea is to understand which type of workloads, AI workloads are currently active or being piloted in your organization, being planned. You can look at just the top 3 maybe. Or possibly you might have thought of some workloads, after today's discussion, your minds might have changed. So just, look at your top 3 priorities, submit them. Okay, so 2 people have responded. Predictive analytics, edge AI. 3 people have responded. Some more are still left. 4 have responded. There are 13 of you in the room today, so I'll expect a lot more changes in this.
I have to go to poll.
Sorry?
I have to go to poll.
You just have to select the top 3 options and click submit. That's it.
When you select based on tick mark coming, so there's a confusion.
Just refresh it, maybe. Slide down. Submit is at the bottom.
So when you select all, it doesn't show it is selected. So
No, it's actually showing. I just take the option, drag it in that box, one after the other. It's not multiple checkboxes. You have to drag them to the top box.
I missed the first
Yeah.
statement.
So 7 people have responded. I'm still waiting for 6 more responses. Some people are still left. You responded? Okay. Okay. So Gen AI has obviously the most popular vote, understandably. Predictive analytics, talking about demand forecasting and maintenance, and then ML model training in-house or on the cloud. Those are top 3. AI-driven security ops. So 8 people have responded, still waiting for 5 more people. No, you just read on the maximum option select, that's it. Color code is just for us to easily read. 10 people have responded, 3 more left. think 12 people are only in the room, so 2 more people left. Who has not yet responded? Achha, your phone is outside. What about you? Oh, your network is one. Okay, so I guess then we'll have to count you out, but if you can get the network, then maybe the next question you can participate in. So this is interesting insights. I didn't want to kind of get into too much of a discussion on this, but I think it's fairly self-evident as to what are the top use cases that are being considered either by you or by your customers, the AI use cases. And I'm sure that, some of the things that you heard probably will have some merit in, incorporating some of that in these applications. If anybody, so I'll not go one by one, but if anybody wants to make any comment on any of the things they selected, you can just spend a minute or so telling me about it, about why you chose the options you chose.
Okay.
Yeah, please go ahead.
Yeah, so-
Say your name also and the company.
Yeah, so, hi. Yeah, hi, I'm Rajesh. I work for Capgemini.
Okay.
So I've selected 2 options: machine learning model and generative AI.
Okay.
I'm sure we all know why generative AI is
Right.
quite popular today. I think I'll talk about machine learning more because
Okay.
we are a consultant, right? We are a consultancy company. So what we do is that we want our young professionals to train more, so that what we want, they should understand in-house and cloud more. So that is where that technology itself, we have our own bots, and we have the engineers who are creating bots and all. So they'll have to understand this more.
Okay.
So it's like, I think we also said that we have to be educated more to work on AI later. We're all talking like Cloud9 stuff, but I think I think machine learning is something that I picked, and then of course I could not say about generative AI because I think there are a lot of people will.
Right. There's plenty of things. Everyone's talking about Gen AI, so no problem. Great, wonderful. Anybody else wants to share before we move to the next slide? Okay, so next we want to ask, what are now your infrastructure priorities that are critical for your organization's AI, over the next 12 months. So basically, now that you've kind of opted for the top 3 use cases and you heard about the requirements for infrastructure to be AI ready for AI workloads, what are the priorities now? So again, you can choose the top 3 if you want. It's easier. No need to go down below that. So just select the 3 options. I've got 2 responses so far. Ensuring data security and reliability at the hardware level. 29% is scaling real-time data processing across the edge and cloud. Modernizing storage and memory infrastructure for agility and scaling real-time data processing across the edge and cloud seem to be the top 2 priorities. We still have 1 more response left. Yeah, 1 more has come now. So modernizing storage and memory infrastructure is for agility. That's good, Rajesh, because I think it worked. The people understand the value of storage and memory, and so that's great to hear. Anybody wants to talk about the options they chose and why? Really, you want to give a shot at it? No? Okay. What about you? Yeah.
Yeah, 2 reasons. Okay, why I chose modernization. Okay, so because anyway, we are talking about sustainability in today's world. We are talking about do more with less, right? More higher compute, but with more kind of your sustainability and all, right? Data center space is very thinking and it's costly affair. At the same time, power is also costly affair. At the same time, compute requirement is very, very high. Right? So it's high time, okay, to re-architect the different design of the infrastructure. And that's the reason that we are talking about the modernizations. Modernizations that we want for that. And the second part I chose it about your data security and reliability. Security is something which I say the security first. So whatever we design, okay, we as a platform engineering, okay, we ensure that security is by design. So whatever we design, the security first in our mind. This is of that, okay, building an entire architecture design. So that is the
Shyam, you want to add anything?
Just all I agree with those pointers. But again, sustainability is something that we need to take care of. And for me, I will prioritize sustainable goals. It is also related to BRSR. And for limited companies, that is also under BSA advantage. So apart from it, life cycle management, green energy, sourcing through all these things, plus ethical AI, what we are talking about, just hardware, but I am also concerned about real-time output. So scaling real-time data, that is also top priority in my list.
Peter, you have something to add?
I actually had a different one, so I selected the top 3 out of the list that was there, starting with the data security at the hardware level first. Because till the time the hardware level core is not safe, nothing else matters. Of course, apart from that, I also looked into the sustainability and the modernization of the storage and memory, because that's why you upscale, you look into the other factors also. And I'm completely in agreement with what my colleague also mentioned in the real-time data processing, because no matter what you have, how you're going to use it and how the output is going to come to you at what time frame really matters. So that's why I had those 3 in the top priorities.
Okay, great. What about this side? Any options you want to discuss?
They have covered most of things.
No, what are the options that you chose and why?
So, with increasing the AI workloads, real-time data processing with accuracy and less latency is going to be a big challenge. And that's where I think companies like Micron will play a pivotal role. Once we understand the new architecture and the importance of it, and AI workloads is going to be the next game changer. That's what we can see with agentic AI getting more popularity day by day. So, again, if he says whatever they said, if that is true, and memory can be utilized in a better way, we can reduce the number of servers and other things, which will improve the TCO and other things. So definitely it will be a win-win for everyone, and that's where I think we are moving in the right direction.
Wonderful, wonderful, great. You want to add something?
Yeah, I think I selected, of course, sustainability and managing power and cooling for growing AI workloads, because we have many data centers across the globe.
Right.
And so that's the challenge that we have, and our group also have the sustainability goals right on our head. So those are the larger goals that we see.
Yeah, by crunching infrastructure into lesser form factor and making it dense, I think that can also help you meet the sustainability goals.
Absolutely, absolutely.
The way technology is moving.
Yes.
Wonderful, great.
Yeah, one more I have, that is the green data center. I'm sure it is one of my priority, but go green is
No, absolutely. In fact, that's why I mentioned in the beginning that, according to NASCOM, about 70% enterprises aim to reduce the carbon footprint in the data centers in the next 2 years. So I'm glad that I'm hearing it directly from you all.
It's important for us also. In fact, the basic fab I talked about will be net zero.
Yeah, so we will jump line now.
Rajesh, you want to give any comment on what you just heard on the summer that
No, I think again, thanks for your. This was Anil's kind of summarizing. Again, the objective is so that me and my team, if we are able to understand what kind of thought process you have, and it goes back to the initial, I think, comment that Peter made. How do we sort of develop more data and then push out? Our end goal is we are a commodity product, but there is so much associated with it. How do we increase the awareness about how you can sort of really look at memory and storage right at the time when you are thinking of a new architecture, new upgrade, new data center, and I think our job will be done if that helps in making a more efficient data center for us. So for us, it was all this feedback that we have received is very useful. We hope we are in a very early stage. We hope the the structure we had in the session, talk about the technology. I think Hammerspace, Deepak shared, you would have found it very interesting. We found that it's good to bring some of our key partners. So thank you for taking your
So Rajesh, I have a question for you. So I think what is the innovations like? I mean, like you are saying it's a commodity product, right? Which was not the case, right? When we first the memory was introduced, it was never, nobody thought it was going to be a commodity which we are talking about. So what is the innovation? And you also mentioned that you had a bad time, right? During, so there was no demand. So what changed for Micron to become what they are
No,
today?
sure. Okay.
Was there any innovations or, because technology is same, right? And for you, NVIDIA, Samsung doesn't matter, it's same. So what changed for Micron?
No, so the reference I was talking about is more of how market treats the products the way it is utilized. The point I was making is, look at any semiconductor. We are talking about CPUs and GPUs. Look at the CPU and GPU. What is the perception you have? You have a perception, it's an extremely high-tech product. When was the last time you negotiated an Intel CPU price, or you thought about, is there what kind of options are available? In your perception, it's a high-tech product. It's and then you are willing to explore and look at different options. Other side of the coin, the same semiconductor product, same complexity, goes through the same model, capex, etc. But up until now, treated as a commodity within the system. Because anything that is a commodity goes through commodity cycles. Commodity cycle is demand supply. There is more demand, less supply. Market will pay the right price. If there is more supply than demand, then market commoditizes. So that's why I was saying the fact that for 1.5 years we sold almost at half the price of manufacturing, that would never happen for a GPU or a CPU. So my commodity reference is a high-tech product. Now, how it pushes a company like a memory company is, our R&D roadmap doesn't stop, right? All the things that Rohit shared tells you a relentless R&D engine followed by a relentless manufacturing investment. Again, from our CPU discussions, you keep hearing 15 nanometer, 5 nanometer, 3 nanometer. We have the same, our notes are also same. And he talked about 1 alpha that is less than 9 nanometer. So we are putting the same investment, and then we were burning cash, which was a very difficult period for a company. So you have to find out a way that you have to keep investing in R&D, you have to keep investing in manufacturing. Now the upside has come because suddenly there is increased investment in AI. So the demand supply is mad. We are able to get cost plus for the products. So that was the reference and the tough time that was. So that was a tough time I was talking about. Other than that, I think over a period of time, the way technologies are perceived and utilized changes. And I think
I would love to add is, earlier you were communicated like, even if you increase memory, performance won't increase.
Yeah.
So that was the kind of.
If I may say, for long part of my career, 16 years I was selling Intel CPUs. If I wear my old Intel hat, my presentation would have been very simple. It's about the CPU, nothing else is important. But now if some of my relative comes and tells me that my laptop is struggling, I am able to give the right advice and just double the DRAM and see.
99% of the time, 99% of the time, the bottleneck is always CPU, not the CPU. So,
you can test it. If you have an old 5-year-old laptop, just double the DRAM, just see.
nobody would say to change the CPU, right? They would say add the memory or add the storage.
So look, that is how it is. But I think the good thing is, because of the AI, because of increasing workloads, even a normal laptop today, if you put 8 GB, for example, Windows 11, they demand that you have at least 16 GB. So I think that's an interesting journey, and the change in the direction is helping us then to put
that investment back in manufacturing.
One more way I agree, which OEMs, your product works best in?
So, sorry to cut you short, but I think since we're running out of time, we will continue our discussion offline. Just one last item in the agenda. In your badges, there is a QR code also there, behind your badges. That's a feedback form. We request you all to just spend a few minutes, scan it and submit the feedback form.
I'll just take 1 minute.
Yeah.
It's been late, but everybody has been very patient. I don't want to skip this. I don't want this to be messed up. I mean, a word of thanks to you, Rajesh, and especially to you, Anil, the CMR team also. I'm looking at a very small scale of size of people who are sitting out over here, but I understand that this matters a lot. For everybody who's come over here, they've invested their time and energy, especially that you all have taken the space and you all have got this everything done. You've got a very strong team, I would say that. You guys are very calm, you all know what you'll talk about. You only try to do any sales pitch, you only try to sell anything, you only try to persuade us, prove and talk about us. But whatever you all spoke really meant a lot. Including even the CMR team. I'll tell you why I'm saying this. Because they called me up and they said, we'll arrange for your cab and everything. I said, that's fine. If I have to get something for myself from the people that I'm working for, who are trusting me, I need to go and invest my time also. So I did a cab and all. Then I was a little dicey because marriage is like 2-3 marriages over here. My 2 phones kind of found off, the battery was down, the power bank battery was down, and luckily a lady called up and I said, I'm here, I just need to know which marriage is it. She guided me, so I reached, and I was worried that I will get stuck in the traffic. I was traveling. I in fact came with my bag and I traveled, and I wanted to make sure that I avoid the traffic and I reached early. But in this entire conversation that we had in the last 2 hours, everybody has been very keen and they were listening to you all carefully what you spoke about, which matters a lot. Thank you once again, and including the CMR team also. I'm sure what will have passed across to 12 people will get multiplied into hundreds surely. And once again, thank you. Thank you everyone. Whoever is there.
Thank you so much.
Yeah, I endorse what Peter has said. In fact, I have a cigarette from Tata Motors and I was the largest buyer for decades, at least in India. My IT budget was 10,000 crores, but this aspect we never looked this closely. And for Tata, energy efficiency, sustainability matters a lot. In fact, it did not matter saving cost. In our plant in the last 50 years, the entire canteen food is cooked on solar power. When solar power was not cheap. So I'm just saying you have a lot of other benefits, not only necessarily selling certain cents or dollars, but they're very important. So thank you very much.
Yeah, so given the technology that has been done by Micron, I'm sure the farmer must be very rich now. Yeah, so the different kind of chip. Oh my God. So great, thank you so much. Please just submit your feedback form and then look forward to meeting you over cocktails and dinner. Yeah, thank you so much.
Doing and working with the entire ecosystem. So usually you go through the qualification. Ultimately, the competitive nature is such. All the 4 or 5 OEMs end up adopting. The challenge always is who is the early mover and who is not. Our request to you, that is why always is, get your teams to demand some more. What happens is, in their scheme of things, the pressure is the inventory. Even if they know that you are working on a new data center.
If you buy a mobile, the company sells. The other company. It should work well. That's what it is. So that's it.
No, because what happens is OEMs are net integrators. So and OEMs value add in today's world is yeah.
There are so much wafers only being created, and with those wafers,
if that is, there is some.
No, it also mostly depends on time to market. Some of them will.
And they are no at times is primarily that they want to sell rotation rather than.
Actually, sometimes they don't like this.
Earlier,
our friends find out that we have this conversation, so they feel uncomfortable. But then we always think that we tell them that you don't buy from us, but you are a customer. That's why.